Thank you, David, and thank you for inviting me. I was sort of talking to somebody the other day about sort of the path of my career, and it occurred to me that in technology, the moment that you understand something is generally the moment that you should move on, because it's the moment that it's become boring, and you should always be kind of looking for questions that you don't understand, because that's where all the kind of the interesting things are. And it struck me, there's a famous quote from Bertrand Russell, a British philosopher, who said that the whole problem with the world is that the fools and fanatics were always so sure and the wiser people are so full of doubts. I'm not sure if quite how far I count on a scale of wiser people, but I think one of the sort of key things to understand about generative machine learning, large language models, is, as David was saying, how new they are and how uncertain everybody in the industry is. It feels a little as though everybody has spent the last year walking around kind of holding onto the top of their head with both hands going, holy fucking shit, this is amazing. What is it? And we're still kind of trying to work out at a lot of different levels, well, what actually is this technology? What does it do? Where is it going to go? And so I thought it would be kind of useful in that, let me sort of share my slide, in that context, just to start by zooming out a little bit. There we are. Does that work? Yeah. Okay. So I'd start by talking about new technologies and S-curves. This is a very kind of classic, well understood framework that new technologies tend to start not working. They tend to start by developing slowly, and people say they're a toy, they're stupid, they don't work, they're useless, no one would want that. The enterprise version tends to be it won't scale. And the general question is, well, very clever, but why is this useful? And then it goes through a period when it's very exciting, and maybe you should get a job in it, or your children should get a job in it. And then it reaches a point where it's boring, and it's just the way the world has always been. And I think that very obviously is now where smartphones are. 15 years ago, smartphones were amazing. Today, the new iPhone is amazing, but it's also boring. It's like it's another smartphone. It's a pocket supercomputer that 5 billion people have, and it's boring. And this is also, I think, where machine learning has gone in the last 10 years. So machine learning was sort of a stupid idea from the 1980s that had never worked. And then in sort of 2012, 2013, it starts working. And in the last decade or so, it's gone from an amazing, exciting idea to something that's now kind of well on the way to being sort of well understood and fully deployed. And there is an old joke in AI research that AI is anything that doesn't work yet. Because once it works, people say, well, that's not artificial intelligence, that's just software. That's just a database, that's just translation, that's just image recognition, that's not AI. And somehow AI is always the problem that hasn't been solved. And so if we go back to what the world looked like in 2013, which I think one could kind of call sort of version 1 of machine learning, which is when it starts working, excuse me, there's an academic image recognition competition called ImageNet, and machine learning starts working, and it produces images like this. And I would go to big companies or civil servants and say, I would show them this, and they would say, very clever, well done. Why is this useful? What are we supposed to do with this? And you could show things like this. This was kind of an early image recognition demo to show how difficult this problem actually was. And it would work, but it wasn't clear why this was useful. And we kind of went, in the last 10 years, we went through this process from, okay, image recognition works, to working out like what's the right level of abstraction to understand this. That really this is pattern recognition. And then we have to work out, well, what is pattern recognition? What problems could you turn into pattern recognition that maybe didn't look like pattern recognition to begin with? And there are many things that did not look like recognizing cats or dogs that turned out to be image recognition problems. We're now kind of going through that process again with a second wave of machine learning. I think it's a kind of a useful way of describing it. This is sort of another wave that people call generative machine learning. Sometimes people talk about large language models. In general, I think when you talk about AI, it's useful to go one level back and be specific about what technology you're talking about. It's more useful to talk about machine learning or large language models than to say AI, because I sort of suggested earlier, AI could mean anything. And so again, we have these amazing demos. So here is Midjourney. Midjourney can now, AI can now make cat pictures. So I type that in, I get that out of Midjourney. I ask for a song about Tesla and SpaceX, and I get a song about Tesla and SpaceX, and it scans and rhymes. It's a song. This is amazing. I can also ask it to explain something or give me an itinerary Or, if I'm going to go to Barcelona next week, instead of having 20 tabs open in Google, I can just ask ChatGPT, what should I do? And so this gets people very excited about what this might do to the web or to search or to Google. I can ask it to make products. So the image on the bottom left here is a product shot from Shein. The other 3 images from Midjourney using the Shein product description. And those aren't quite ready to send to a factory yet, but this is clearly just now an engineering question, not a science fiction question. And then you can go a bit further and say, well, what if I could ask this to explain something? So there's an old engineering joke that a Russian screwdriver is a hammer. You just hit it harder. And so you can ask ChatGPT, can you explain this, please? And it actually produces not a bad explanation of what this might be. And so this has all been, in the last year, as we all know, very exciting. ChatGPT has apparently had 100 million users and $1 billion of revenue. And McKinsey did this survey of their client base and found that basically everybody has tried this. Certainly well over 75% of management in big companies have at least tried ChatGPT, and 10-20% of people are using it every day. So this is all very exciting. However, imagine you have invited Benedict Evans to speak at a conference. This is something that happened to me earlier this year, and you want a nice long biography of them, and Benedict has only given you a short biography. So you use ChatGPT, and you get this. It says Benedict is prominent, important, hugely influential, which is all true. Went to Cambridge, worked at Anders Analysis, worked at Andreessen Horowitz. Yes, this is correct. Reload. Oops, no, he went to LSE and worked at Financial Times and worked for ABI Research. No, actually he did go to Cambridge, but he worked for The Guardian and then worked for Atlas Ventures. And so this is this thing that OpenAI call hallucination. I don't think that's what it is. People also call it bullshitting, or they say this is the overconfident undergraduate who will answer a question without knowing. I also don't think that's quite right. What's happening here is it's matching a pattern. So it never says I went to Sciences Po or MIT. It never says I studied theology. It's always the right kind of job and the right kind of degree. And so this is something that somebody tried earlier this year. They asked, what's the most cited economics paper of all time? The answer is a paper that doesn't exist, but it looks like what a paper like that would look like. So what kinds of papers? Which authors? What kinds do they have co-authors? What kinds of subjects? What kinds of journals? So it has set, what it's actually done is it said, what would the most cited economics paper look like? What kind of writer would have written it? What kind of journal would have published it? I think you can see this more clearly if you look at an image generator. So earlier this year, I asked Midjourney to make me an imaginary 1960s French sports car. So this is a very cool French sport. It looks French. It looks like it's in a French house. It looks kind of Citroen. It's got like a 1960s coloring. It has 2 steering wheels and no door. And it's not lying. It knows that shapes like this have shapes like that in roughly that place, but it doesn't know what steering wheels are. It's just matching the pattern. Now, this can be very deceptive, and I think it's particularly deceptive when you're looking at text because the prose is perfect. And so you tend to have perfect prose, but the model behind the prose isn't perfect. And the same thing here, the optics and the perspective and the color and probably even the reflection are perfect, but it doesn't know what a car is. So you're sort of misled by the surface. So this is a survey that Deloitte did in the summer. People who have used generative AI think it's accurate. So you have to kind of use it quite a lot and test it and press it to start understanding what it's doing. And as you do that, you realize that when you use these things, you're not actually saying answer this question. What you're actually doing is saying, what sort of things are in the training data that might look like answers to questions that look like your question? And so you get a lot of kind of puzzles of what this is. This is not a database. It's not Google. It's also not Napster. It's not a piracy system. There are lots of copyright content in the training data, but the copyright content is not in the model, and it cannot give you the copyright content back. A great framing that I saw recently was to say that large language models tend to be bad at things that computers are good at, and good at things that computers are bad at. So they are good at writing songs, but they're very bad at giving you the same answer every time. The framing that I've always liked is to say that AI gives you infinite interns. And I used this about the last wave of AI. So you would like somebody to listen to every single call coming to the call center and tell me if the customer is angry or if your service agent is being rude. You don't need an expert for that. You could get a 15-year-old to do that. In fact, you could probably get a dog to do that, because dogs do have general intelligence, unlike large language models. But you don't have enough interns. Well, AI lets you automate that. It lets you automate anything you could get a 10-year-old to do. And the same thing kind of applies here. So if you go back to this biography, if they had emailed me and said, Benedict, we want a 700-word biography of yourself, I would have said, oh, fuck, I don't want to do that. That's going to take me hours. So instead, I could go to ChatGPT and say, write a 700-word biography of myself, and then I could fix it. So again, that would give me an intern. Or you can be an ad agency and you say, give me 500 ideas for this, and I'll pick the 50 that I really like. Again, this is sort of automation of what you might get an intern to do for you. Now, if we shift back to how people are trying to think about this, there's a sort of a base level that says, okay, this is one of these every 10 or 15-year changes that come through the tech industry, like the iPhone, like the web, like open source or cloud, indeed like the last wave of machine learning. For the next 5 or 10 years, every new company will be built around this, and then there'll be something else. There's another level of excitement that says this is more like an every 20 or 30-year thing. So Bill Gates said this summer that when he went to Xerox PARC in the 1970s and saw graphical user interfaces for the first time, he realized this was a step change in who could use computers, because you wouldn't have to learn command lines to type into the computer. You could just click on what you wanted. However, somebody had to have made the things you're clicking on. Someone still had to have made the software that you were using with a mouse. And now, in theory, you can just go to ChatGPT and ask it to do something. You can go to an LLM and ask it to do something, so you don't need hundreds of different tools. You maybe have many fewer tools all running within one piece of software. There is then, I would say, a third set of people, a much smaller group of people, who think that this will take us to what we call AGI, artificial general intelligence, a computer that is alive and intelligent and aware in the sense that people, or perhaps dogs or horses, are alive and aware. That is a conversation I'll come back to in a minute. But meanwhile, since I've talked about platform shifts, we should kind of think about platform shifts. As I said, every 10 or 15 years, the tech industry has gone through one of these shifts that resets what everything in the tech industry is built around. It was mainframes, and then PCs, and then the web, and then smartphones. And as you go through these shifts, there's a common set of questions that repeat every time. So there are a lot of engineering questions about how are you going to build this, how's it going to work, how's it going to scale. There's a set of value capture questions about who will make all the money, and then there's a set of questions around, well, what will the actual product be, as opposed to all of the concepts and demos. And those all, of course, feed off each other and reinforce each other. And so today with generative machine learning, we have a bunch of engineering questions. Most obviously, these models, the L in large language model is important. This is the first time that it's actually cost real money every time a consumer presses OK in a consumer app. And so there is a gold rush to acquire the processing power to run this, to get the models to be smaller, to get the models to run faster. And NVIDIA at the moment is overwhelmed by demand for GPUs. There is also a whole set of questions around how many models there are going to be. Will we have sort of 2 or 3 Velt computers and everything else plugs onto that? Or will this look like every other wave of computer science? And it will, maybe in 10 years' time, there will be as many machine learning models as there are spreadsheets or databases, and trying to regulate models will be absurd. We don't know. And then, of course, there's the question of what the product will look like. Because every time you get these new technologies, to begin with, you make it fit what you already do. And then over time, you change the way you work in order to fit your job. And we're now kind of going through that process as this technology gets absorbed into product. And so what always happens is that the incumbents always try to make it a feature. So now we see Google and Microsoft adding LLMs to every aspect of Google Sheets and Google Slides and Outlook and Gmail and so on. Then startups get created that try and unbundle some piece of the incumbent, some peel some business app into a new company. And every now and then, you fundamentally change the nature of the industry. So I think Uber is kind of an interesting as an example here. This is a sort of a story that got a lot of attention now 9 years ago. A finance professor in New York said Uber isn't worth very much money because, first of all, the global taxi market is $100 billion. Secondly, Uber will only get 10%. Therefore, it's not worth $17 billion. So reality, a decade later, was that Uber actually got $60 billion, and the entire conception of what the addressable market was wrong. what Uber was not doing was taking a percentage of the taxi market. Uber was changing what the taxi market actually was. And that's kind of the third step when you actually change what the market could be. Now, of course, Uber is, amongst other things, a regulation and a policy question. And so I thought I would talk, given the audience, about policy. Now, this is, again, something I made in Midjourney with this prompt. So Cindy Sherman is a fine art photographer. I ask it to make me a picture in the style of Cindy Sherman. Now, if you go to an art gallery in Paris or London or New York and look and say, what do you think about this? They will shrug, like, that's not a problem. But there's a whole other category of kinds of artists and creators who get very upset by this. If I go to Google today and say, tell me some news, Google will give me links to newspapers, and I will click on them, and I will go and give the newspapers some business. And the idea that Google should be paying the newspapers to send them business is, let me pick a nice scientific word, bullshit. The more academic term, I think, would be rent-seeking, privileged rent-seeking. But if I can go to ChatGPT and say, explain this news story. So this is a story about the cancellation of a high-speed rail project in the UK. And so I did this last week. I can go to ChatGPT and say, explain this story, and it goes and reads 5 news websites and explains it to me. Now, at this point, the complaint of a newspaper, or indeed any publisher, becomes very different. And already a huge number of publishers have started blocking ChatGPT. Now, to be clear, what's happening here is, this isn't in the training data. What I've done is I've told ChatGPT today, go and look at the web and work out the answer and explain it to me. So it generated that the moment I asked the question. So this gets us very obviously a conversation about regulation. And I think one should probably start by saying, well, every big important industry tends to get regulated. We regulated railways and food and aircraft and cars. And in the last couple of years, we've had an awful lot of effort to regulate the internet or to regulate software. And now we talk a lot about AI. And, you know, it's a sort of a basic problem that we have here is that, you know, software became the world. Everyone is using software all the time. And so all the world's problems get expressed in software, and so we regulate it. But I said a moment ago, we regulate cars. That's not really true. We don't regulate cars. We regulate 10 or 15 or 20 different things. And the people who worry about collision safety or emissions or the way that General Motors treats its suppliers are different. And they are different from the people who ask, should Paris have cycle lanes? Or should Amsterdam be pedestrianized? Or what do we think about deploying charging points for EVs? These are all different questions. And most of those questions are complicated. And most of them have trade-offs. A nice illustration of this was produced by an advocate for public transport. This is not a competition problem. You can't go to General Motors or Ford and say you have to do this. You can't break up General Motors to make this happen. Their competition, technology regulation is complicated. And so this is, meanwhile, of course, you have to ask, well, what does success look like? So this is a chart of annual deaths from car crashes in the USA. I should update this chart because it's gone up a little bit in the last year or two. So you can look at this chart and say this is a complete failure of 50 years of car safety. You could also look at it in terms of deaths per passenger mile or per car, and you can see, oh, this has actually been hugely successful. And so you have to work out, well, what does success look like? In a world where we didn't grow up with this, we spent 100 years understanding how cars worked. We grew up with cars. We understand what it would mean if you were proposed a new regulation for cars. We did not grow up with software. We did not grow up with Facebook, and now we did not grow up with AI in the same way. And we're not going to wait 100 years to work out how to do it. But I think a kind of a key point to make here is that there's a sort of very common framing where technology people say, oh, technology policy is complicated and it's full of trade-offs and you don't understand. I think that's slightly the wrong way of looking at it. Really what technology people are saying is, no, technology policy is no easier or simpler than any other kind of policy. It's just as difficult as transport policy or healthcare policy or education policy. And so that takes me finally to talking about regulating AI. I think there's a sort of a primary problem here, which is to ask, well, what problem is it that we're trying to solve? Are we trying to solve problems of people doing bad things or foolish things with software? And machine learning, and now generative machine learning, creates new ways that you can do bad things or foolish things with software. Are we worrying about geopolitics and data centers and the dominance of large companies and large economies and whether this important new technology will shut out Europe? Or are we worrying that we're going to produce some intelligent life form that will kill us all? Well, we might worry about all of those things, but those are completely different kinds of problem. And one thing that I want to kind of throw in here, which I think as a British person, I'm very conscious of, I'm honestly not sure how many people in the audience are familiar with this. This is a huge scandal in the UK in which the Post Office deployed a new computer system that had bugs that showed shortfalls of cash. And the Post Office believed that all of its staff were stealing and ignored the bugs and went to court and claimed that there were no bugs. Hundreds of people were prosecuted. A number of people committed suicide. It took 10, almost 15 years for the Post Office and Fujitsu to admit, no, this is all caused by bugs in the software. This is not artificial intelligence. It's not AI. It's not large language models. This is 1970s technology. And yet this is happening 5 and 10 years ago. And so each of these new waves of technology creates new ways that this can happen. What happens if people do bad things with software? What happens if people don't understand the software? This creates kind of a new class of problem. And we kind of try and work out, well, yes, but how do we work out the right way of regulating those? You know, we do not have a database regulator who would have stopped this. This is kind of a judicial system problem, but there is no SQL regulator. There is no Oracle regulator who would have prevented this. So a couple of final comments, and then we have time for some discussion. We came out of the pandemic. We got very excited about a huge acceleration, and then we kind of returned to the trend line. So this is a chart of e-commerce in the USA. It spiked up in the pandemic and then returned exactly back to the trend line. This chart looks much the same for pretty much in every industrialized country. It's just the levels are higher and lower. The UK penetration is a lot higher than this. French penetration is a lot lower. There's an old joke that when the apocalypse comes, you want to live in France because everything happens 5 years later there. And that does seem to apply to technology, excepting obviously any French people on the call who are all, I'm sure, early adopters. But e-commerce is kind of boring. There's one thing that I wanted to talk about just to illustrate this at a more kind of instinctive level, that we all sort of grew up with software, but I think we kind of forget how important it became. And I think this is a good illustration of that. This is data for online dating in the USA. 50% of new relationships in the USA now start in dating apps. And so what's happened is that software was on computers and technology were always kind of interesting and exciting, but they weren't part of everybody's lives. And now they've become part of everybody's life and a basic part of the way that we all live. And that, I think, changes the way that we think about all of these policies. But as I said earlier, because it's happened so quickly, it's harder for us to understand quite what it means. And with that, I will say thank you. And I think that's exactly 20 minutes, so we have time for some discussion.